Hello everyone. Today we will start voltage equation of alternator. Already we have completed the construction of alternator, and the next and very important topic is voltage equation of alternator. So let us concentrate. The voltage equation of alternator means how the EMF is induced and what is the equation of the EMF induced in the alternator. Already we have completed the working and the construction of alternator. Now, before going to the voltage equation of alternator, we need to know some specific term, which is first one is full pitch coil and the second one is short pitch coil. So what is full pitch coil and the short pitch coil? Right? Just look at the diagram first. See, we already know for in the rotating part, that is for the case of alternator, we are creating a north and south pole. So if the armature windings are in the stator are just comes under the both north and south pole. If we are considering a single turn coil, please mention the specific words, that is single turn coil. If each turn it comes under both north and south pole, then it is known as full pitch. If the coil distance is less than north and south pole, then it is short pitch. So see, when the angular distance between the two coil sides is one pole pitch. One pole pitch is the called the angular distance. That is means, what do you understand by one pole pitch? One pole pitch, which means the distance between the north pole and the south pole. That is known as one pole pitch. Clear this one? One pole pitch means the distance between the north pole and the south pole is known as the one pole pitch. Now, if the two side of the coil, if the two side of the coil distance is one pole pitch, then it is called full pitch coil. Clear? Means the distance between this two side of a coil must be equal to the distance between the north pole and the south pole. That is known as one pole pitch, and the coil is known as full pitch coil. This means both sides of the coil sides are lying under the pole in full pitch coil. This means both the coil sides are lying under the full pitch coil. Clear? Both sides lying under the full pitch coil. Just try to follow the cursor. That is north pole and south pole. The distance is known as one pole pitch. And if the two sides of the distance having one pole pitch distance, the angular distance between the two sides of the coil, the angular distance between the two sides of the coil is one pole pitch. That is known as full pitch coil. Now, the short pitch coil, if the angular distance between the two coil sides are less than one pole pitch. So the angular distance between that is the angular distance of the two sides of the coil. Just try to concentrate. That is the angular distance between the two sides of the coil is less than one pole pitch is termed as short pitch or fractional pitch coil. Here, the coil span or coil pitch for short fractional pitch is less than 180 electrical degree. Here, so the distance between the north and south pole, there is one pole pitch means electrical 180 degree. We are considering, also we have all for the last in machine 1, for the case of DC machine also you might have studied this one. That is the distance between the north and south pole, which is known as one pole pitch, is nothing but the 180 degree electrical. And I hope you also know the distance, that is the electrical degree and the mechanical degree. Electrical means the distance between the north pole and the south pole is known as 180-degree electrical. But for the case of mechanical, the degree we also already know. That is the 180-degree or 360-degree, 90-degree, those are things. But when the distance between, we are considering the distance between a north pole and south pole, that is 180-degree electrical. So the full pitch coil, the distance between the two side of the coil, the distance between the two side of the coil is known as one pole pitch, which is for full pitch coil, and less than one pole pitch, that is or less than 180-degree electrical, is known as short pitch coil. The next one is pitch factor or the coil span factor. So already if we know that the equation of full pitch and the definition of short pitch, so it is clear that the EMF induced in a short pitch coil must be less than the EMF induced in the full pitch coil. See, the pitch factor is, or the coil span factor, is defined as the ratio of EMF generated in short pitch coil to the EMF generated in full pitch coil. It is denoted by Kp and its value is always less than unity. Here, why it is less than unity? Because already we know that is the EMF induced for the case of short pitch coil. The EMF induced for the case of short pitch coil must be lesser than the EMF induced in the full pitch coil. Okay. The EMF induced in the short pitch coil is less than the EMF induced in the full pitch coil. That's why it is the pitch factor is always less than 1. This factor basically represents the effect of short pitch winding on generated EMF across the winding terminals of the electrical machine. Now, if we are having the stator winding, means for the case of alternator, already we know that the armature winding is in the stator. So the stator winding, if it is having more number of short pitch coil, then the total EMF generated will be less. Try to understand. If the stator have more number of short pitch coil, then the total EMF induced is less. But EMF induced in the, if we are having more number of full pitch coil, if we are having more number of full pitch coil, then we are having much higher EMF at the stator terminal. Clear? So our objective, mostly we will be using the full pitch coil. We will always try to do the full pitch coil, but we might have the short pitch coil also. Clear? Now we have to concentrate some other things, that is distribution factor and winding factor. So distribution factor is defined as the ratio of phasor sum of the coil's EMF to the arithmetic sum of the coil EMF. It is also known as belt or braid factor, denoted by Kd. Okay, the phasor sum of the coil EMF and the arithmetic sum of the coil EMF. If we do the phasor sum, always we know that is a root over sum, and arithmetic sum means just adding the EMF. That is known as distribution factor. And the winding factor is defined as the ratio of EMF induced, that is EMF generated in short pitch, and distributed coil of the EMF generated to the concentrated winding coil. It is denoted by Kw. Winding factor is nothing but the ratio of EMF generated short pitch distributed coil and the concentrated coil. Distributed means the coil is, we have more distance. Concentrated means the short pitch coil are more nearer to each other. Okay, so try to understand pitch factor, which is very important, the ratio of EMF generated in short pitch to the ratio of EMF generated in full pitch. Distribution factor, ratio of coil phasor sum of the EMF and the arithmetic sum of the EMF. And winding factor is the distributed winding and the concentrated winding. Now, before going, that is the EMF equation of alternator. So what is that EMF equation of alternator? Now, let us assume that F, obviously, we are having F is the frequency of the induced EMF, N is the synchronous speed, P is the number of pole, F phi is the flux per pole, Z is the number of conductors. So, and we are having distribution factor is sine m beta by 2 and divided by m sine beta by 2. Okay, and the form factor also already we know, know the definition of form factor is 1.11. That is, we are having conductors per phase connected in series is 2T. Now, in one revolution of the conductor, each stator conductor cut by a flux of phi p. Now we are having phi is the number of flux and p is the number of poles. So the total flux cut in one rotation is phi p. So the rate of change of flux is d phi equals to phi p and the time is 60 by n, where n is the speed in RPM, rotation per minute. That is, dt is 60 by n, means 1 second. If we are having n speed in 60 seconds, means 1 second, the speed is in 1 second is 60 by n. So the average EMF induced per conductor is d phi by dt, that is phi p by 60 by n, that is become phi n p by 60. Now we know that F equals to P n by 120, already we know. N equals to 120 F by P from the induction motor. Substituting the values of N above equation, the average EMF per conductor. So the average EMF per conductor become 2F phi, that is dP by 60. In place of N, we are putting 120 F by P. And now the 60 is 120, it will become 2 and this P and P will cut each other. That's why it's become 2F phi. Now, if there are Z conductors in series or parallel, then average EMF per phase is equals to 2F phi Z. Okay, it's become 2Z. 2F phi was there, we are multiplying with the Z, and we already know Z equals to 2T here. Z equals to 2T. That's why it is become 4F phi T volt. Now the RMS value of EMF per phase is become, now we are changing from average value to the RMS value. This is the average value you are getting 2F phi or 4F phi T. So the RMS value becomes, we have to multiplying with 1.11, that is it's become 4.44 F phi T. 4.44 F phi T. So the actually available voltage per phase. Now you have to consider whatever we have studied, that the pitch factor, distribution factor and the winding factor, that is Kc and Kc, Kd, and it become Kc, Kd, F phi T. Kc is for pitch factor, Kd is for distribution factor. Okay, so it's become 4.44 Kc, Kd, F phi T. We have to consider the short pitch and full pitch. Either it is distributed winding or the phasor sum. Okay, so it's become 4.44 Kc, Kd into F phi T. Clear? So this is the end of your EMF generated per phase. So do remember this equation, 4.44 Kc, Kd, F phi T. In the next class, we will do the voltage regulation part.